Now we are going to study next chapter, Simple Harmonic Motion. Everyone give the heading. Simple Harmonic Motion. Next chapter that is we are going to study is what? Simple Harmonic Motion. In shortcut we denote it by SHM. Okay? SHM means Simple Harmonic Motion. Everyone give the heading. Simple Harmonic Motion. It means SHM. Now guys, in that write down, we have to write down few theory. What is meant by SHM? Okay. See, SHM is a periodic motion. See the word. SHM is what, everyone? What is meant by SHM? SHM means, SHM is a special type of periodic motion. Everyone, write it down. Everyone, please write it down. SHM is a special type of periodic motion. SHM is a special type of periodic motion. SHM is a special type of periodic motion which satisfy the following two conditions. Okay, so SHM means what, everyone? SHM is a periodic motion. SHM is a special type of periodic motion. Means it is a periodic motion. Now what is meant by periodic motion first of all, guys? So you have written SHM is a special type of periodic motion which satisfy the following two conditions. Okay, now before going further, which two conditions it satisfy? First of all, we are going to understand what is meant by periodic motion. Periodic motion means what? The motion which repeats after certain interval of time. The motion which repeats itself after certain interval of time, then that motion we call it as a periodic motion. What is meant by word periodic motion means what, everyone? Periodic motion means what? The motion which repeats itself after certain interval of time, that motion we call it as a periodic motion. And our simple harmonic motion is also one of the type of periodic motion. Okay, so you got it. So SHM is a special type of periodic motion which satisfy the following two conditions. Okay, everyone getting my point? Try to understand the scenario here. Now what are the two conditions? Everyone write down the first condition. Everyone write down the first condition. So what you have written till now? SHM is a special type of periodic motion which satisfy the following two conditions. Now write down the first condition, everyone. Acceleration is always directed towards a fixed point. Guys, write it down. What you have to write down? Acceleration is always directed towards what, everyone? Acceleration is always directed towards fixed point. Another name of fixed point, what? Midpoint or mid-stroke. Fixed point. Guys, see, acceleration is always directed towards fixed point, mid-stroke, midpoint or mid-stroke. Okay, guys, are you getting my point? This is the first condition. Everyone completed first condition? Now second condition, guys. Second condition. Write it down. Acceleration is proportional to acceleration is proportional to acceleration is proportional to acceleration is proportional to distance from fixed point. Acceleration is proportional to distance. What, guys? Acceleration is proportional to distance from what, everyone? Distance from fixed point. What is the another name for fixed point? Midpoint or mid-stroke. Okay, guys, are you getting my point? So acceleration is proportional to distance from fixed point. Okay, I will explain you what is the meaning of fixed point here. Okay, I will explain you what is the meaning of fixed point or mid-stroke here. Okay, everyone completed this second point. Now I'm going to give you example of which motion we can consider as a which periodic motion we can consider as a periodic motion. So the motion which satisfy these two conditions, the periodic motion which satisfy these two conditions, we can consider that periodic motion as a simple harmonic motion. In shortcut, we denote it as SHM. Okay. Anyone have any doubt in this discussion? Now try to see the scenario. Now we are going to study example of simple harmonic motion. Example of simple harmonic motion. Motion of piston. Motion of piston can be considered as, guys, what we can say? Motion of piston can be considered as SHM. So in our piston cylinder engine, okay, in piston cylinder arrangement, means in our engine crank slider mechanism, motion of piston can be considered as what? Everyone listen my words carefully. Motion of piston can be considered as what? Motion of piston can be considered as SHM. Okay, now try to see the scenario here. I'm going to explain you a few important points with you guys. Okay, see, suppose this is what our piston, this is what a cylinder. See the scenario here. Very, very important discussion, guys, we are doing. This is what a cylinder. This location is what? Everyone, topmost location is what? TDC. TDC means what? Top dead center. Bottommost location is what? Everyone, what is bottommost location? Bottommost location of the piston is what? BDC. TDC stand for what? What is the meaning of TDC, everyone? TDC means what? Top dead center. And what is meant by BDC? Bottom dead center. Okay, try to see the scenario here. Now in this cylinder, suppose this is the particular position of the piston. Okay, this is the particular position of the piston. This is what a piston, this is what a cylinder, this is what a suppose connecting rod. So see the point here. Here I am going to explain you a few important points here, and this is very, very important to understand the things. So this is what a connecting rod. This is a schematic drawing, guys. Actually, you know how a piston cylinder means piston cylinder in engine works. All these things you know already. So this is what a connecting rod. This is what a crank here. Try to see the point here, everyone. Okay, everyone getting my point? Try to see the scenario here. So here, see, this is what a crank. Try to familiarize the words, terminologies. This is what a, guys, this is what a piston. This is what, everyone? This is what a connecting rod. Everyone, try to see the wordings here. This is what a connecting rod. Then this is what a, everyone, crank. Okay, now this crank is in what? Crank is in what? Crank follows circular motion. Everyone, try to see the scenario here. This crank follows what? A circular motion like this. Crank follows rotational motion, and this piston follows what, everyone? Piston follows what, everyone? What the piston follows? Piston follows SHM. You got the meaning of SHM? Everyone, try to understand the wordings here. So guys, see the point here. When our crank at this location, everyone, try to see the point here. I'm explaining you very, very important point with you guys. Suppose, just assume that our crank is rotating like this. Our crank is what? Suppose this point here. See this point, everyone. Suppose our point is at this location. Suppose this point, suppose crank is at this location. At this location, guys, at the bottommost location, what will be the position of piston, everyone? Suppose if the crank at this position, everyone, at bottommost position. What will be the position of piston for this scenario, everyone? Position of the piston is at BDC. Okay, good. When crank goes to this position, what will happen, guys? When crank goes to this position, what will happen, everyone? What will happen? Position of the piston is what? TDC. Means our stroke for this scenario, guys. You got the meaning of stroke? See, I am going to explain you meaning of the stroke. So here, so this is what, suppose I will say R. What I will say here? Guys, R. R stand for what? Everyone try to see the scenario. I am going to explain you very important concept. The important concept is what? Stroke. Okay. Important concept that I am going to explain you. Stroke. So this is what a TDC. This is what a BDC. So distance between, length between TDC and BDC, guys. Huh? Those who studied heat, they may know this term. So this distance is what? Stroke. Now guys, observe this drawing. This one. Crank, and this is what? This stroke. What is the relation between crank radius? What is the crank length, or we will say R? So crank length, this is what our crank R, and what is the relation between that stroke, guys? Everyone, what is the relation between this crank, means this circle radius R, and this stroke? Can you tell me, explain this relation? Everyone try to see the scenario. What will be the relation, guys? What will be the relation between R and stroke? See, I am going to explain you once again. See, what will be the stroke, guys? when our this crank position is at this location, guys, what will happen? So our piston is at TDC. When our crank go down, when it comes at this location, so by how much distance moved by this point, guys? How much vertical distance moved by this point? How much vertical? Means from this point to this point, this distance will be what, everyone? 2R. So whatever the distance, vertical distance moved by this point, means when it is coming from this to this point, how much vertical distance between these 2 points, guys? 2R. So the same distance will be TDC to BDC. So here we can say stroke is equal to what we can say? What we can say? 2R. What we can say, guys? Stroke is equal to what? Everyone? 2R. Anyone have any doubt in this discussion? Everyone getting my point? So here, and see, I will explain you what is the meaning of fixed point. See, here we understand, we defined one term, fixed point, midpoint or mid stroke. Okay. So exactly in between, guys, what is the meaning of fixed stroke or midpoint or mid stroke? Exactly center of the stroke. What is the meaning of that word, guys? Fixed point, mid stroke, fixed point, midpoint or mid stroke. Exactly center of the stroke means what? Our fixed point. Everyone getting my point? Try to see the scenario here. Huh? Anyone have any doubt in this discussion, guys? Everyone got this drawing? Motion of the piston can be considered as, motion of the piston can be considered as what? SHM. So here, as the piston moves from, suppose TDC to BDC, the distance moved by the piston is what? Stroke. That stroke will be equal to 2R. Okay. So this crank length. R means what? Our crank length. Okay. Anyone have any doubt in this drawing? Try to observe the scenario here. Huh? Okay. Before going further, guys, please draw this diagram and then we will see further scenario here. Please everyone draw this drawing. Now try to observe this drawing. Now we are going to combine these two motions. Here this motion is what? This point is what? This end point of the crank is moving in what? Everyone, end point of the crank is moving what? Moving in a circle. Then this point, this piston is what? Piston is following reciprocating motion. Okay. Try to see the scenario here. Huh? Here this point is what? Moving in a circle. And this point means piston is following reciprocating motion. And what we are going to do now? We are going to combine these two motion. What we are going to do? We are going to combine motion of this point and the motion of the piston in a one reference circle. Try to understand the reference circle here. Consider a point Q. Everyone, please write it down. Consider, leave it after 2 lines. Guys, leave the 2 lines. Leave the 2 lines. Consider a point Q. Consider a point Q. Consider, okay, everyone, consider a point Q. Point in single quotes. Consider a point Q moving along a circle. Consider a point Q moving along a circle with constant angular velocity omega. Consider a point Q moving along a circle with constant angular velocity omega. Try to see the scenario here. Here I am going to explain you very important concept. Now don't write anything, don't do anything, just listen my words carefully. Don't do anything, guys. Just listen my words carefully. Now here I am going to draw one reference circle. See this one. This bigger one is what? A reference circle. So this is what a reference circle. Guys, observe the scenario. This circle must be big. You have to draw the bigger circle here. So consider this circle is like a motion of this point. Everyone, consider this circle. The circle that we have drawn now is the motion of this point. Just imagine that I have drawn the enlarged view here. Okay, try to see the point here. So point Q is moving on the circle. What is here? Suppose this is water. Here there is a point Q. Here it is point Q. And this point Q is moving on this circle. Okay, everyone, this circle is visible to you. Now try to see the scenario here. So now here I am going to draw one diameter AB. Okay, what I am going to do? I am going to draw a diameter AB. This is what, everyone? This is what? Diameter AB. Okay, this is what a diameter AB. Try to see this. This is what a vertical line, everyone. So this is what a diameter AB. Okay, so this topmost point is what? A point, and then bottommost point is what? B point. Okay, now try to see the scenario here. Then below that guys, write it down. Next point, below that line. Okay, first line what we have written? Consider a point Q moving along a circle with constant angular velocity omega. Okay, omega means what? Constant angular velocity omega. This is the meaning of omega. This sentence we have written. Now the next sentence, guys, in the next line, let point P. Okay, let point P. Everyone write it down. Let point P. Let point P. Let point P be the, let point P be the, let point P be the projection of, let point B be the projection of, everyone see the word, let point P be the projection of point Q, projection of what, everyone? Projection of point Q, projection of point Q on the diameter, on the dia AB. On the dia AB as shown in figure below. On the diameter AB as shown in figure below. Try to see the point here, everyone. As shown in figure below. Okay, everyone get my point. Let point P be the projection of point Q on the diameter AB. Okay, everyone getting my point? Try to see the scenario here. Now, what is the meaning of word projection here? So here, what is the meaning of word projection? Those who know are drawing basic concepts, guys, during your class 4 or in your drawings also, that concept is what? Projection. Projection means what? Here from this point Q, what we are going to do? We are going to draw one line, one horizontal line. This line is visible to everyone. Try to see the point here. From point Q, what we are going to do? We are going to draw one horizontal line on this diameter AB. Okay, and this point, what this projection? This point is what? So here this is what a projection of point Q on diameter AB, on this diameter AB. So this projection means what, everyone? What is this meaning of projection? What is the name of this projection point? We have given P point. Now suppose this point Q is what, guys? Point Q is what? Moving in a circle, moving in a circle, moving in a circle. Suppose point Q reaches here. We will say here it reaches at a point Q1. Then corresponding projection will be what, everyone? What will be the corresponding projection? What will be the corresponding projection, everyone? Corresponding projection will be what? So corresponding projection to Q1 to, so with Q, P will be the projection with respect to Q1. Then corresponding projection will be what, everyone? We will say P1. Okay. So this is what our Q1 with respect to Q1, P1. Now see the point here. Suppose point Q starts from here. Point Q starts from here. When point Q moves, guys, see the point here, everyone. When point Q moves like this, corresponding projection point P also move on this diameter AB. So see the motion of two things. Means when point Q starts from here, corresponding projection point P also on the B point. Suppose point Q, Q for queen. Point Q, suppose Q starts from point B. Then at this location, point P will also at that point, same point. Means at B point, at this bottommost point, point Q and P point are the same. When point Q starts moving on this circle with constant angular velocity omega, try to see the point with constant angular velocity omega, then corresponding point Q will also move. See the point here. When point Q reaches here, corresponding projection is what, P1. And when point Q reaches at point A, then corresponding point P will be what, guys? Corresponding point P will reach it at point A. Everyone getting my point? Try to understand the scenario here. Now suppose point Q reaches here. Now point Q going here, going here, going here, going here. The corresponding point P will go down, down, down like this. And when it is at this location, everyone, when point Q is at this location, we will say that is Q2. Then corresponding point P is what, everyone? What will be the corresponding point P? What will be the corresponding point P? Corresponding point P will be what, everyone? We will say P2. Okay, everyone getting a point? See, I am explaining you once again. Suppose motion of point Q starts from point B. When motion of point Q starts from point B, then corresponding point P is what, at this same location. Now when point Q reaches here, when point Q reaches at this location, the corresponding point P will be at this location. Then when Q goes like this, corresponding point P also goes like this, goes like this, goes like this. When point Q reaches here, corresponding point will be what, guys? This one. When it reaches at a point A, when point Q reaches at a point A, then corresponding point P will also reaches at a point A. Everyone getting a point? Everyone try to understand the scenario here. Now suppose here, now the next point will be what? Now our Q is moving in a circle. So when Q here, when Q goes this further, then corresponding point P will go down, will go down, will go down, will go down. And when point Q reaches at this location, everyone observe the scenario. What will happen? The corresponding projection of point Q will be this point P2. Means what? When point Q goes from this, follow this circle, from this semicircle, corresponding point P will go from what, guys? From this point to this point. Everyone getting my point? Means when point Q goes from this, follows this semicircle, corresponding point P will go from B to A on this linear motion. Now when point Q follows this semicircle, then corresponding point P will be what, guys? It goes from A to B. Everyone observe the scenario here. I am going to explain you further things. Now suppose our point Q reaches here. Suppose what happened, guys? Our point Q reaches here. We will say that point as a Q3. Then corresponding point P will be what, everyone? Then what will be the corresponding? That corresponding point will be what, everyone? That P3. Okay. So now if you observe the scenario here, when point Q follows the circular motion, what will this point P is doing? When point Q means what, queen? When point Q moves complete one circle, when point Q complete one circle, guys, what happened with point P? What happened with point P? point will follow, point P will do one reciprocating motion. Means point P starts from point B, it goes to the point A and again come back to the point B. That's happened with point P. This point P, everyone getting my point? When point Q follows one complete circle, moves in one complete circle, then what happened with point P? Everyone, what happened with point P? It does one reciprocating motion. You got the meaning of word reciprocating motion? Means it starts from point B, it goes to the point A and again coming back to the point B. So here the motion of point P. So here motion of point P can be considered as a simple harmonic motion. Guys, listen my word carefully here. Here motion of point P. Here motion of this point P, guys. This motion of point P can be considered as a simple harmonic motion. Okay, everyone getting my point? Now, how these two things are related with each other? Try to see the scenario here. Now, see, when guys, try to understand the scenario here. So here in this drawing, what we have done, we merged two motions here. What we have done on this drawing, we merged two motion of this drawing. One motion of this point, guys. So consider this point as our point Q. Consider this point as what we can consider, guys? We consider this point as what? Point Q. And then this piston means what? Our point P. So everyone getting a point? So here piston is doing what? When our point Q do one complete circle, try to see the scenario here. Suppose point Q starts from here. What happened with here? When point Q is at this location, guys, what happened with piston? Piston is at BDC. When point Q is at this location, what happened means when point Q moves this circle like this, then piston goes from BDC to TDC. And then when point Q goes from this location to this location, what will happen? Piston goes from TDC to BDC. Everyone getting my point? Try to understand the scenario here. So here what we have done, we have combined these two motion of this point, that is what our point Q, and point P is piston motion. We combined these two motions in a single drawing, guys. Everyone getting my point? Try to understand the scenario here. Okay. So here, anyone have any doubt out this? So what is the meaning of this point A? What is the meaning of this point A, everyone? What is the meaning of this point A? Point A means what? TDC. Point A means what? Our TDC. TDC stand for dot day center. And point B means what, everyone? BDC. So what is the meaning of point P? Point P means what? Our piston. Okay, what is the meaning of point P? Point P means what? Piston. Motion of piston means motion of this point P will be our motion of piston. And then next point, this end point of the crank. This end point of the crank will be what? What this will be what, guys? Our motion of point Q. Everyone getting my point? Try to understand the scenario here. And this exactly at the center, guys. Exactly at the center. Okay, 1 minute, guys. You have to draw the circle properly. My circle is not that much proper, but you have to take a proper compass, and by using compass, okay, by using properly compass, by that using, you have to draw the circle properly. So exactly at the center. Exactly at the center is what, everyone? Exactly at the center, what we have? Guys, exactly at the center, what we have? Fixed point. What is the another name for this fixed point, guys? So this is what our fixed point, or another name for fixed point, everyone? Midpoint. Another name for midpoint. Mid stroke. Okay, guys, everyone familiar with this word? Fixed point, midpoint. Okay. Now try to see the scenario here. Now again, so here, suppose angle covered with respect to center means our piston going from this point is what? Our Q1 point. This is what? Our Q1 point. So now angle covered. Everyone try to understand the scenario here. This angle covered, here I am going to draw one dotted line. Here this dotted line. So this angle covered is what? Here this angle covered is what? A theta. This angle covered is what, everyone? Theta. Try to see the scenario here. Now before going further, everyone, before going further, I have to give more notes here. Then first of all, before going further, first of all draw this drawing. And what is the name of this circle, guys? What is this name? This is what our everyone, this is what a reference, we will say reference circle. Okay, and this actually, guys, see, actually motion is there, what? Motion of, what is our target? Our target is what? To study the motion of point P. Because point P is following simple harmonic motion. But in some scenario, we need this reference circle also. Not in every numerical, but in some numericals, we need this reference circle also. In that scenario, we have to use this concept. Okay. While dealing with the numerical, I will explain you more use of this reference circle. And guys, see here, show this angle theta properly. And don't get confused with point Q and this theta. Okay, everyone. So please, everyone, first of all, draw this drawing. Then I will explain you further things. Now everyone, please write it down. Here, everyone, please write it down. Here, motion of point P. Motion of point P. Here, motion of point P can be considered as, here motion of point P can be considered as simple harmonic motion. Here, motion of point P can be considered as simple harmonic motion. Here, motion of point P can be considered as simple harmonic motion. Okay, everyone completed? Anyone have any doubt in this discussion? Good. Now try to see the scenario here. Now we are going to understand few more points here. What that means? Now see, in exam we never draw this, means only except few numericals we don't draw this drawing, guys. Huh? We don't need that reference circle and all that things. We never need that point. Now in exam, which diagram we prefer? We will see that. Now before going for that, write it down here. So I told you, here point Q is moving with what? Guys, constant angular velocity. Point Q is what? Moving with constant angular velocity omega. So guys, see, whenever we have a constant angular velocity, see the point here. When point Q reaches from this point to this point, when point Q reaches from Q to Q1, then corresponding point P will be what? Reaches from P to P1. So here, so this point Q is making how much angle, everyone? Point Q is making how much angle with respect to center? Theta. So here, then write down, everyone. Omega is equal to what, guys? Theta by T. Please everyone write it down. Omega is equal to theta by T. And what is the relation for, what is the unit for omega, everyone? What will be the unit for omega, everyone? What will be the unit for, in radian per second? Very good. Unit for omega is what, everyone? Radian per second. Anyone have any doubt in this discussion, guys? Okay. So unit for omega is what here? In radian per second. Good. Now try to see the scenario here. What the question? Now the important point is here. Everyone completed? Please write it down, this one. Omega is equal to theta by 2 T in radian per second. Okay, good. Now try to see the scenario here. Now what I told you just few minutes before, 1 or 2 minutes before. See, in exam we never prefer this drawing except 1 or 2 numericals. In all others drawing we never draw such type of drawing reference circle. Then this. See, what is our target here? What we are studying? Simple harmonic motion. And here which one is following simple harmonic motion? This point P is following simple harmonic motion. Try to understand this thing here. Oh? Okay. Here which one is following simple harmonic motion? This point P is following simple harmonic motion, and we don't need this reference circle, guys, except 1 or 2 numericals. In all other numerical, we don't need this reference circle. So whenever we have a such type of scenario, whenever we have simple harmonic questions, our favorite drawing is what, guys? How to show the motion of piston or motion of point P which is following simple harmonic motion. See, here I have given you one example of piston, but it may be your wall of the engine, okay, that will also follows the simple harmonic motion. Then slider crank mechanism. In slider crank mechanism, slider is also. Now guys, see, few minutes before I explained you piston and cylinder arrangement with the crank and connecting rod. Then that which follows that mechanism, we call it as a slider crank mechanism. In one numerical, I will explain you that also. So before going further, everyone try to understand this scenario here. Before going further, so how to draw, which diagram is favorite for us from exam point of view. So here I am going to show this line will indicate what? What this line indicate, everyone? Motion of the piston or motion of the point P, which is what? This is what? A straight line, everyone. Okay, I am making it properly straight. Okay, everyone, what this line indicate? Motion of the piston. Now this topmost point is what? What is the topmost point, everyone? What is topmost point? TDC, or we will say top end. Okay, what we will say? TDC or top end. Then this will be what, everyone? Bottom means what? BDC, or what we will say? Bottom end. Now distance between these 2 points, between the TDC and BDC will be what, everyone? What will be the distance between TDC and BDC, everyone? Distance between TDC and BDC will be what? What will be distance between these 2 points? Distance between these 2 points. What is the name? Just now we studied, everyone. What will be this distance? Distance stroke. Okay, correct. So this distance between TDC and BDC is what? We will say stroke or total travel. Okay, everyone getting my point? Then exactly at the center, what will be there? Exactly at the center, what will be the, which point will be there? Exactly at the center. This point will be what, everyone? What will be this point? This point will be what? Fixed point or mid stroke or what? Midpoint. Everyone getting my point? Everyone getting? So this is what here. Now the next scenario here is what? In our drawing of the piston cylinder arrangement of the engine, there I have shown you few things, guys. There I have shown you few things there. If you remember my point, see this total distance, stroke means what? What I have given to you, guys? Stroke means what? I have given to you. Stroke is equal to what? 2r. What I have given to you? Stroke means what? 2r. So here this distance will be what, everyone? What will be this distance? What will be this distance then? What will be this distance? Stroke is, so this distance will be what, everyone? This distance will be what? We will say this distance is what? R. If this is R, means from mid stroke to TDC R, then again mid stroke to BDC will be what? Then this distance will also become what, everyone? This distance is also become what? R. And R has a name, guys. R has a name. And what is the meaning of R? R means what? Amplitude of SHM. What is the meaning of R, everyone? What we call it as R? See, basically R is the radius of this reference circle. Basically R means what? Radius of the reference circle. But in SHM, what is the meaning of R? What is the meaning of R? R means what? Amplitude of SHM. What is the meaning of R, everyone? What is the meaning of R? R means amplitude of SHM and it is the radius of the reference circle. Guys, see this circle, this reference circle. So see, what will be the radius of this reference circle, everyone? Add R here. On this drawing, everyone, on this reference circle drawing, add R here. On this drawing, please everyone add this R. So R means what? Amplitude of SHM and it is the radius of the reference circle. And here stroke is equal to what, everyone? Stroke is equal to what, everyone? Always 2 times r. And stroke total travel, or we will say lift also. What we will say? Lift also. Stroke, total travel, lift, all are the same words. Everyone getting a point? Try to understand the scenario here. Now suppose there is a one point, guys. There is suppose point P. Suppose there is a what? A point P is here. Okay, everyone try to understand the scenario here. There is a point P which is at a distance x from a fixed point. Which is at what, guys? Consider a point P which is at a distance what? How much distance, everyone? Consider point P which is how much distance from fixed point? So this distance is what? We assume this distance as a what? We will assume x. X means what? What is the meaning of x? What is the meaning of x, everyone? Distance from what, everyone? What is the meaning of x? X means what? Distance from fixed point in meter. Okay, everyone getting my point? So now before going further, this as a, see, what is the meaning of x? Distance from a fixed point. Now my question is, what will be the lowest value of x, everyone? What will be the lowest value of x? What will be the lowest value? 0. And what will be the highest value of x? Lowest value of x is 0. See what I told you, it is distance from fixed point. It may be on this side or it may be on this side. So lowest point means what? This point P can be at fixed point or this at TDC. So where it is at fixed point? When x is at fixed point, when point P is at fixed point, then what will be the value of x, guys? 0. So x is 0. Or when it is at TDC. When it is at TDC, what will be the value of x, everyone? What will be the value of x? X means distance from fixed point, r. So we can say x always in between r less than or equal to or greater than equal to 0. Everyone getting my point? So value of x is always in between less than r, less than or equal to r, and greater than equal to 0. Anyone have any doubt in this discussion? You got the meaning of r, you got the stroke is equal to 2r, you got this one. So value of x can be anywhere. Means if you consider point P instead of this side, we can consider point P on this side also. So, and what is the meaning of x? X means what? Distance from a fixed point. And it values when it is at, when point P is at fixed point, then x is 0. When point P is at TDC or BDC, x value will become r. Okay, anyone have any doubt in this discussion, guys? Try to understand the scenario here. Now before going further, everyone draw this drawing. Beside this drawing, write down this point, everyone. Write down properly, everyone. Complete these things. Now everyone, try to see the scenario here. Velocity of point P. See the point here. Next point. Velocity at point P. Velocity at point what, everyone? Velocity at point P, and point P is how much distance from fixed point, everyone? At a distance. Velocity at point P at a distance what, everyone? At a distance x from what? From where? From fixed point. Everyone try to see the scenario here. So velocity at point P at a distance x from fixed point. Then what will be that velocity? So this velocity v is equal to under root of omega. Sorry, v is equal to omega into under root of r square minus x square. And what is the meaning of r? R stand for amplitude of SHM. So in this scenario, we will get the velocity. And what will be the unit of velocity, everyone? What will be the unit of velocity? Velocity means what? In meter per second. Now the next point will be what? Acceleration at point P at a distance. What will be the next point, everyone? Acceleration at point P. Acceleration at point P at a distance what? How much distance, everyone? At a distance x from where? At a distance x from where? From fixed point. Another name for fixed point is what? Fixed point, midpoint or mid stroke. So what will be that acceleration? Acceleration will be equal to what? Omega square into x. Okay, we don't go into derivation of this relation, guys. We have to memorize this relation and we don't need that derivation also. And it in what will be the unit of acceleration? Acceleration is in what? In what will be the unit of acceleration, everyone? Acceleration is in meter per second square. Okay, everyone, please write down these two relations. Very, very important, this relation to us. So now, guys, what we got? We got two relation. Means what? When we are at point P, distance from fixed point will be what? When at point P, velocity will be what? V is equal to omega r square minus x square, and acceleration is what? Omega square into x. Now, everyone, please go to our second note. Everyone, please go through means first definition of simple harmonic motion. Everyone, go through the definition of simple harmonic motion. Everyone, go through the definition of simple harmonic motion. And while defining first definition, guys, the first point of this chapter, simple harmonic motion is a special type of periodic motion which satisfy following two conditions. Condition number one is what? Acceleration is always directed towards fixed point. That is condition number one. During numericals, I will explain this condition. But what is the second condition, everyone? Acceleration is proportional to distance from a fixed point. What is the acceleration, guys? Acceleration is distance from a fixed point. And what is the meaning of x, everyone? What is the meaning of word x, everyone? What is the meaning of word x? X means what? Distance from fixed point. So if the distance is more, everyone try to see the scenario. If distance from fixed point is more, then acceleration will also have a higher value. Means distance x has a higher value, then acceleration will also have a higher value. Okay, guys, are you getting my point? Try to see the scenario here. Means what is the meaning of that word? Second point, acceleration is proportional to distance from a fixed point. Means what? If value of x is higher, then acceleration will also higher. If value of x is lower, then acceleration will also have a lower value. Anyone have any doubt in this discussion, guys? You got that point? Okay. Now try to see the scenario here. Next few points are very, very important to us. I am going to write it down 3 notes to you guys. 3 important notes. Now before that, first of all, I am going to write down this relation once again. So V is equal to what? At point P, omega is equal to what? Under root of r square minus x square. Acceleration is equal to what? Omega square x square. Try to see this relation, everyone. So these relations. Now, first of all, note number 1. Guys, what? Note number 1. Note number 1. What will be the note number 1? We'll say. Suppose at fixed point, everyone. At fixed point, what will be the value of x, everyone? At fixed point, what will be the value of x? At fixed point, what will be the value of x, everyone? At fixed point, what will be the value of x? Guys, I told you, value of 0. Means x means what? Distance from a fixed point. If our point P is at fixed point, value of x will be what? At fixed point, x is equal to what? 0. Anyone have any doubt in this discussion? Guys, at fixed point, x is equal to 0. Now the next point will be what? So x is equal to 0. So what will be the then velocity will become? See, what will then velocity will become? When x is equal to 0. When x is equal to 0, what will velocity become, everyone? What will velocity? Velocity, see, I am going to see. See, here I am going to write down this relation omega under root of r square minus 0 square. So this term will become what? V is equal to omega under root of r square. So square root of r square or under root of r square will become what? So V is equal to what will become? R. Means square root of r square will become what? Again R. So it means what? At fixed point we will get the value of V is what? V will become V max, and we will get that will be equal to omega R. Everyone getting my point? So at fixed point, velocity will become what? V will become V max. Velocity will become what, everyone? V will become what? V will become V max, and that V max is equal to what? Omega into R. You got my point? So at fixed point, V will become V max, velocity will become V max, and that will be equal to omega into R. Now what about acceleration, everyone? What about acceleration? What is the expression for acceleration, guys? Omega square into x. Means omega square, x is what? 0. So anything multiplied by 0 will become what? So this term will become 0. So acceleration will become 0. Anyone have any doubt in this discussion? Please everyone write it down. Please write down these points, everyone. Everyone completed? Only this point, guys. You don't have to write down anything. This one. You don't have to write down. Okay. Now next point, second point. Second note, everyone. Try to see the scenario here. Second note. Now we considered fixed point, everyone. Now we will consider TDC or BDC. At TDC or BDC. At TDC or what, everyone? Or BDC, top dead center or bottom dead center. What will be the value of x, everyone? What will be the value of x, guys? X is equal to what? Distance from fixed point. So it will become what? X will become R. Now velocity will become what, everyone? So here instead of x, we will put here x is equal to what? We will put R square. So here x will become R square. So R square minus R square, it will become 0. So what will velocity will become at fixed point, everyone? Velocity will become at TDC or BDC, velocity will become 0. Now what about acceleration, guys? Acceleration means what? Omega square into x. So here whenever the value of x is higher, then acceleration will also have higher value. So what will be the highest value of x? Highest value of x is what? R. So corresponding to R, whatever the acceleration value, that will be our maximum acceleration. So A will become what at that point? A max, and A max will become what? Omega square R. Everyone getting the point? Try to understand the scenario here. So at TDC or BDC, velocity will become 0, V will become 0, but acceleration will become maximum acceleration, and maximum acceleration is equal to omega square R. At fixed point or mid stroke or midpoint, x is equal to 0, velocity will become maximum velocity, and that will be equal to omega R, and acceleration is 0 at that point. But at TDC or BDC, x is equal to R. At this TDC or BDC, value of velocity is 0, and acceleration become maximum acceleration, that will be equal to omega square into R. Anyone have any doubt in this discussion? Now third point, guys, before going further, what will be the value of third point? Third note. See. Now everyone, suppose if we consider 2 point, everyone. Suppose if we consider 2 point, everyone try to see the scenario. If we consider, try to see the drawing here. I am going to draw 1 point. This is our line diagram of that one. Same drawing I am going to draw. This is what suppose TDC. This is what our BDC. And exactly in between our fixed point. And here suppose I am considering point A. Suppose this is what a point A, and this is what a point B. This is what a point A, this is what a point B. Distance of point A from fixed point is what? Suppose XA. Distance of point A from fixed point is what, everyone? XA. And distance of point B from fixed point is what, everyone? What will be the distance? We will say XB. Okay. Try to see the point here. Distance of point A from fixed point is what? XA. Distance of point B from fixed point is what? XB. Suppose if XA is equal to XB, if what? XA is equal to XB, then what we can say, everyone? If distance from fixed point is same on either side, means XA is, A is on one side, B is on another side. If distance from fixed point is same, then what will we say, guys? Value of velocity is what? Velocity is depend on, see guys, omega and r for that particular motion is fixed. So if the value of x is same on both side, on this side, on the top side or bottom side of fixed point, if the value of x is same, then what about velocity guys? We can say if the value of x is same, then velocity of the point A and point B will be same. So we can say then velocity at point A is equal to velocity of point B, and what will be the next point here? And acceleration is also depend on what? Acceleration is also depend on x, because omega is constant here. So if the value of x is same for both the points, then by default acceleration will also same. So between point A and point B, velocity is also same and acceleration is also same. So acceleration of point A is equal to acceleration of point B. Anyone have any doubt in this discussion guys? This one and this point. Okay, whenever we have this scenario given. Guys, any doubt in this note 2 and note 3? Note 3 is very important. Note 2 is very easy, but note 3 is very important. In one numerical we have to use this note. So guys, please write down note 2 and note 3. Everyone please complete. Now note number 4 everyone. Note number 4. Forces in the, please write it down. Forces in the direction of acceleration. Forces in the direction of acceleration. Forces in the direction of what? In the direction of acceleration can be considered as positive. Forces in the direction of acceleration can be considered as what everyone? Can be considered as positive. And opposite forces. Forces in the direction of acceleration can be considered as positive. And opposite forces is considered as negative. Okay. Forces in the direction of acceleration considered as positive and opposite forces as negative. Here acceleration of direction is important, and in bottom in bracket write down acceleration always directed towards fixed point. What it means guys? Acceleration always directed towards fixed point. Acceleration is what everyone? Acceleration always directed towards what? Directed towards fixed point. Towards fixed point. Guys, SHM definition. First point of SHM definition. SHM is a simple harmonic motion. SHM is a periodic motion, special type of periodic motion which satisfy the following three condition. First condition will be what? Acceleration always directed towards fixed point. Okay, and I will explain you what this means. I will explain you here. See here, for the forces we will not consider motion. What we will consider? We will consider in this scenario acceleration guys. In this scenario what we will consider? We will consider the direction of acceleration. Means the forces which is in the direction of acceleration, we will consider that forces as a positive and opposite forces is considered as negative. Anyone have any doubt in this discussion? Okay, everyone completed fourth point? Okay, good. Now next point will be what everyone? Everyone completed fourth point? Now next point will be what? Time period. What is meant by guys time period? Time period. Time period means what? Time period means what guys? Time required for completing one oscillation. Guys, everyone give the heading. Next heading. Time period. Time period we will denote it by tau. Okay. Which symbol we will use for time period? We will use symbol tau. Now what is meant by time period? It is defined as time required for completing one oscillation. Now what is the meaning of one oscillation guys? Suppose piston starts from BDC, it goes to the TDC and again coming back to the BDC, it means one complete oscillation guys. See, what is meaning of one complete oscillation? When piston going from BDC to TDC and again coming back to BDC, it means what? One complete oscillation. So time required for one complete oscillation is called time period. Please everyone write it down. It is defined as, everyone please give the heading first of all, time period, tau, and in that write it down. It is defined as time required for completing one oscillation. It is defined as time required for completing one oscillation. It is defined as time required for completing one oscillation. Okay, guys, you got the meaning of one oscillation here. Now, everyone, when, see, we studied, guys, few minutes before, okay, 15 minutes or 20 minutes before, we studied one point, reference circle, all that things we studied. When, see, actually, who is following simple harmonic motion here? Who is, see, we studied one reference circle there. This is what a reference circle here. This is what our reference circle. If you remember, few minutes before, guys, we studied reference circle. Now this is point Q is moving on the circle. Now see, suppose our point P starts from this location. This location is what? BDC. And this location is what? Everyone, what is this location? TDC. When point Q starts from this location, when point Q starts from this location, it is going like this, 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 going like this. Means point Q moves complete one circle. Suppose point Q, what this point Q is doing, guys? What this point Q is doing? Suppose point Q makes one circle. What happened with point P? What happened with point P, everyone? What is the meaning of point P? What is the meaning of point P, everyone? Point P means projection up, and here, so what happened with point P? Point P goes from BDC to TDC and again coming back to the BDC. Means when point Q moves in a one circle, when point Q moves in a one circle, means doing one rotation, one complete rotation, what happened with point B? What happened with point P? What happened with point P, guys? Point P means our piston. When our crank, it complete one oscillation, guys. When our crank moves in, when crank do the one complete rotation, guys, what happened with piston? Piston will go from the BDC to TDC and again coming back to the BDC when crank do the one rotation. Guys, are you getting my point? Try to see the scenario here. It means whenever there is a one oscillation of one piston, whenever there is a one oscillation of piston, what will be the angle covered by the point Q? Guys, what will be the angle covered by the point Q? Whenever there is 360 degree. Guys, what will be the angle covered by the point Q? That is our imaginary point. See, actually point Q is not there. Actually, we are studying the motion of point P. But we need that motion. But for making the analysis simple, we also studying the motion of point Q. So that we will get a more idea. What we will get? We will get a more idea. So, point Q is whenever there is a complete oscillation, whenever there is one oscillation means what? Going from BDC to TDC and again coming back to BDC. What happened with point Q, guys? What happened with crank? Crank is making one complete revolution. One complete revolution means what, guys? How much angle? 360 degree. So in radian, see guys, in 360 degree is not our favorite unit for the calculation. Whenever there is angle single, guys, without trigonometry function, means without sin theta, cos theta, tan theta. So in, guys, if you remember our rotational motion, in rotational motion, what is the unit of theta? What is the unit of angle we studied, guys, there? What is the unit of angle we studied in rotational motion? Because in rotational motion, we studied omega is equal to theta by t. So what will be the unit of theta there? We studied theta means radian. So 360 degree is equivalent to what? How much radian, everyone? 360 degree is equivalent to how much radian? 2 pi radian. So guys, so here we can say, so when point P going from BDC to TDC, point Q is moving how much angle? 2 pi radian. Guys, are you getting my point, everyone? So here, how we can define omega? So few minutes before, guys, we studied omega is equal to what? Theta by t. We studied theta by t. So instead of theta, here how much angle is covering? 2 pi. And how much time is required covering that angle 2 pi? Tau, time period, means See, time period means what? Time required for one oscillation. And how much angle covered in that one time period? 2 pi radian. Guys, are you getting my point? So 2 pi by tau means what? Our omega. Anyone have any doubt in this discussion, guys? So basically tau means what? Time required for one oscillation. And 2 pi means what? Angle covered by what? Angle covered by this imaginary point Q. And how much angle covered by that imaginary point Q? 360 degree, and 360 degree is equivalent to 2 pi radian. So omega means what? Theta by t. So here theta is what? 2 pi, and time is what? Tau. So omega will become 2 pi by tau. Anyone have any doubt in this discussion, guys? Anyone have any doubt in this formula? In radian per second. Otherwise you may think, sir, what is meant by 2 pi? 2 pi is not here on this drawing. Here 2 pi is not there. 2 pi means angle covered by that imaginary point Q. Okay, guys, you got the meaning of 2 pi? So everyone please write down this relation, only this relation. No need to do this one. Okay, just I am giving you some extra points so that you should correlate all the things, so that you should get interest in this topic. So this is time period means what? So from this time period what we will get? Omega. Omega means angular velocity. Okay, everyone completed? Omega is equal to 2 pi by tau in radian per second. Now next definition is what, guys? Frequency. Okay, few days before, guys, we studied one chapter, conical pendulum. Few days before we studied one chapter, conical pendulum, and there was one term. I told you in further future chapters we will discuss that term, frequency. In that question there was one question is there. In that question they ask us frequency, and now we are going to understand the meaning of frequency. Frequency, guys. Suppose in Mumbai, guys, generally local trains are there. Okay, if you visited Delhi, metro trains are there. Okay, local trains are there. So in local trains, in some areas frequency is high, in some area frequency is low. So what is the meaning of word frequency? Frequency means what? Number of trains in particular time. What is the meaning of frequency, guys? In general word, number of trains or frequency of bus is very high there. Means the place I am staying, frequency of trains are very high. Okay, suppose my parents are staying there where frequency of trains are very low. It means what? In particular time there are less. Frequency is low means what? Low frequency of trains. Low frequency of train means what? There are few number of trains in particular amount of time. High frequency means what? There are high number of trains in that particular time. So this is the generalized term, means in our day-to-day use. But according to this one, frequency means what? Number of oscillations in unit time. What is the meaning of word, guys? Frequency. Frequency means what? Number of oscillations in unit time. Okay, everyone getting my point? So what is meant by frequency? Frequency means what? F is equal to, guys, first of all write down, everyone. It is defined as, everyone give the heading frequency. It is denoted by small f. It is denoted by small f. So please write it down. It is defined as number of oscillations in unit time. It is defined as number of oscillations in unit time. Okay, everyone getting my point? And frequency is equal to what? F is equal to 1 by tau. Frequency is equal to what, everyone? 1 by tau. And what will be, guys, we studied in that chapter in conical pendulum. So F is equal to 1 by tau, and it is in what? In hertz. If you are writing hertz, complete, then H must be small. Or in other term, capital H, if you are using abbreviation, capital H, small z, Hz, hertz. Okay, so that will be the unit of frequency. Now guys, see. So here F means what? 1 by tau. Tau means what? Time period. Now if you observe this relation, omega is equal to 2 pi by tau, and 1 by tau means what? What will be the meaning of 1 by tau? 1 by tau means what? F. So we can write down that relation here. Omega will become what? Instead of 1 by tau, we can say 2 pi F. And what is the meaning of F, everyone? What is the meaning of F? F means what? Frequency. So sometimes in numericals, instead of time period, what they will give? They will give frequency, and from frequency we have to find out omega. So for that one we have to use this relation. Okay, anyone have any doubt in this discussion? And what will be the unit of omega? Omega is what? In radian per second. So everyone, please write down this relation, and this relation complete this point.